morning, everyone. Today we are going to discuss some point related to transfer function solutions and Mason's gains formula. Hello, this is Sachin Fiske from SND College of Engineering. So we are considering, as we discussed previously, what is transfer function. As per the definition of transfer function, it is the ratio of Laplace transform of the output to the Laplace transform of the input under the assumptions that initial conditions are considered as a zero. See this diagram. In this diagram, some points are to be labeled, that is R of S, C of S, then some blocks are given, that is G1, H, some points are given to this summing point, that is E and F, with some negative and positive symbols. So while calculating any of the transfer function at the very initial stage, we have to note about this value of S, or what is this S and what is T. So T indicates the time domain function and S indicates the Laplace domain or S domain function. When we are taking the Laplace transform of any of the function, that is C of t or R of t, then we get C of S or R of S respectively after the conversion of Laplace transform. So at the very first stage, as per the definition of transfer function, we know that the C of S in case of the transfer function indicates output of the system and R of S indicates the input of the function. And this every block or every square block indicates the gain of the transfer function. So while starting this solution, very first we have to find out the output side, or we are starting from the output side of this complete block or complete transfer function. Let us start with C of S. So how this C of S will be obtained? So it is obtained by using this block G1 and input to this block G1 as E. So C of S will be in series, and therefore the C of S is equals to G1 into E as per this diagram. Then moving towards this F point, so F is equals to C of S into H. Why H? Because in the written part of the C of S, this H and the C of S are in series. So F will be the output of this C of S and H. Now this E, how this E will be obtained? So E is a function or the summation of this R of S and F from negative side. So therefore E is equals to R of S. R of S will be considered as a positive because this arrow indicating positive towards this E and F indicating negative towards this E, and therefore the output of E is given as R of S minus F. So all these three equations are very easily defined by using this diagram. Now while solving any transfer function, let us consider the C of S. The equation of the C of S can be obtained as G1 in bracket R of S minus C of S in bracket H. So this C of S plus, by solving this equation easily, C of S plus C of S into H into G1. When we are multiplying this G1 in complete this bracket, we get this solution, and it is equals to G1 into R of S. Consider the terms of C1 on one side, no issue, it may be on LHS or RHS, and the remaining terms of the blocks are on the another side. While taking the C of S as a common term from this LHS, inside the bracket only 1 plus H into G1 is remaining, is equals to G1 into R of S. Now what is our the definition of transfer function? Yes, definitely it is the output or Laplace transform of the output to the Laplace transform of the input, and therefore by solving this complete equation as C of S upon R of S, what is remaining on the right hand side? Yes, definitely it is G1 upon 1 plus G1 into H. Moving towards the another solution. See this diagram. How many blocks are there? Yes, it is G1, G2 and H. These are the gains of the transfer function. And the paths are represented as this R of S, G2 and C of S is the forward path. Then one more forward path is R of S, then G1 into C of S, and one reverse path is indicated as this point B to H to F towards R of S. We can't consider this R of S in negative side, okay, because this R of S is added towards the summing point in the forward direction. So consider this one as H into F1. So our first equation in case of the solution is C of S. In the previous slide we discussed start from the output side, that is C of S. So how this C of S will be obtained? Consider here one summing point is there. So which quantities or which blocks to be added in this point? Yes, definitely the block in addition with this A and the block which is in addition with the B. So simply write down C of S is equals to A plus B. Now how this A will be obtained? After the solution of this equation A, we can definitely put down the values of A in C of S. So don't worry about this one. First find out the value of A and B. Okay, so A will be obtained as G1 into E. Don't consider this G2 because it is in forward direction. Just consider this G1 and the terms which is associated with this G1. Okay, so G1 into E is equals to A. Similarly, we can easily find out the values for this B. So G2 into E. Don't consider this path because this path is associated with A term. Okay. After that, for term F, we are considering F is obtained from this H block and from here it is a B block. Why we are not considering this C of S? Because it is moving towards output side, not towards the H side, not towards the path of H. Okay, and at the last one is remaining, that is E. So how this E will be obtained? Yes, definitely E is obtained from R of S and F. So definitely this E is equals to R of S. Here minus sign is there, therefore minus F. So last equation of E will be obtained as R of S minus F. In this way, firstly we have to calculate the different terms associated with this diagram as the different equation. Now see in this diagram, here equation number 2 and equation number 3 have some relations with respect to equation number 1. Why? Because we have to find out the output of this equation as C of S and input of the equation as R of S, and only these two terms are related with the transfer function, because as per the definition of this transfer function, C of S upon R of S we have to find out, means we have to find out the relationship between output to the input. So consider very first C of S is equals to A plus B, and we already have the values of A and B. And what is the value of A and B? A is equals to G1 into E and B is equals to G2 into E. So put down these values of A and B in equation of C of S, means put down the values of A and B in equation 1 as C of S is equals to G1E plus G2E, which gives us G1 plus G2 into E, as E1 is the common and this one is the equation number C. Now another substitution is that equation number 5 into 6. Why 5 into 6? Because in the obtaining equation or the last obtaining equation, one term is E, and definitely we have the value of E from this diagram. So what is E? E is equals to R of S minus F. Just move towards forward because we are getting the values of C of S and R of S by simplification method. So after putting the value of E in this equation of C of S, we get F is equals to H into G2, sorry, C of S is equals to G1, G2 in bracket R of S minus F. Now, substitute equation number 3 into equation number 4. What is equation number 3? B is equals to G2 into E. And what is equation number 4? F is equals to H into B. And after putting this, we get F is equals to H into G2 into E. This is equation number 8. Next step, now put down the value of equation 5 into equation 8. What is equation 8? Yes, F into H into G2 into E, and we already have the value of E. Again, we have to substitute this value of E in this equation so that we can easily get F is equals to H into G2 in bracket. What is E? Yes, E is equals to R of S minus F. By simply solving equation number 9, solve this bracket, this Hg2 is completely multiplied with R of S minus F. Okay, so F is equals to Hg2 upon R of S, simply again Hg2 into F, and by solving easily step by step, we get this value of F as Hg2 R of S upon 1 plus G2 into H. Give this equation number 10. Now, what is the next step? Our main equation is C of S. That is equation number 6 or equation number 7, because 6, by solving this 6 into 7. Here, now substitute the value of equation number 10 to 7. So what we get? This C of S is equals to, in the first bracket, G1 plus G2. And what is in the second bracket? Yes, it is R of S minus H into G2 R of S upon 1 plus G2 into H. After complete solution of this equation number 11, we get C of S is equals to this bracket, and now just simplify these terms, okay, by taking denominator as a common, that is 1 plus G2 into H, and same this make a cross multiplication, that is R of S plus R of S G2H minus H into G2 R of S. Okay, simple, very simple solution is this, and step by step if you are going to solve, you can easily get the solution. So after this, here what is the gain of the transfer function? Gain of the transfer function is C of S upon R of S. Let us consider this one as a T of S, means transfer function of the solution is equals to C of S upon R of S, and it is equals to G1 plus G2 upon 1 plus G2 into H. Now this is for your homework. R of S and C of S are given in this diagram. So which are the forward paths in this equation or this diagram? It is G1, J2, G3 and G4. Okay, one H2 path is given, that is reverse path or feedback path. One more H1 path is there, that is also reverse path, and third reverse path is H2. Why we are solving this forward or reverse path? Because while solving this, while solving poles and zeros, basically we need to identify the forward and reverse path. Okay, now there are some properties of this transfer function, as it is the Laplace transform of the impulse response for zero initial condition. Secondly, this transfer function can be determined from the system input output, and it is paired by taking the ratio of this Laplace transform of which two quantities? Definitely the output of the Laplace to the Laplace of the input. What is the next property of this transfer function? As per the solution of the equation, the transfer function is always independent of the input to the system. Next step, the system having the pole zeros can be found out from this transfer function. As per this definition, as per this diagram, just I told you why this forward and reverse part to be identified. Just find out the poles and zeros, and how these poles and zeros can be found out will be discussed in the next lecture. Numerator always gives us the value of zeros, and denominator always gives us the values of poles. When we are equating this numerator and denominator equals to 0, definitely we get the values of zeros and poles respectively. Then next property of this transfer function is stability can be determined from the characteristics equation. And last one is the transfer function is defined only for linear time invariant system, and it is not defined for non-linear systems. Okay, hope all of you are understanding this transfer function solution and some Mason's gain formula. Thank you.